How to factor a quadratic expression. Our first two expressions involve greatest common factors. What we want to do is determine the greatest common factor of the following groups of terms. Our first group of terms is 5, 10, and 20. Now by looking at this, I can see that 5, which is our lowest number, is only divisible by 5. 10 is also divisible by 5, and so is 20. As you can see here, 5 divided by 5 is 1, 10 divided by 5 is 2, and 20 divided by 5 is 4. These numbers, 1, 2, and 4, cannot be broken down any further. Therefore, our greatest common factor is 5. Our next group of terms, 2x squared, 4x cubed, and 6x to the fourth, looks a little more complex. What helps to factor this is if you focus on the coefficients first. So 2, 4, and 6. 2 is only divisible by 2, and it can also go into 4 and 6. Here you see that 2 divided by 2 is 1, 4 divided by 2 is 2, and 6 divided by 2 is 3. So we have part of our greatest common factor now, which is 2. We still have to do something with these exponents. X squared, x cubed, and x to the fourth. X squared is our lowest exponent, so I'm going to divide x cubed and x to the fourth by x squared. But when dividing by exponents, you subtract the exponents. So x cubed divided by x squared equals x, because 3 minus 2 is 1, so we still have 1 x left. X to the fourth divided by x squared equals x squared, because 4 minus 2 equals 2. So if we combine the 2 over here with the x squared, our greatest common factor is 2x squared. Our next expression is an easy case quadratic trinomial. X squared minus ax plus 12. This is considered an easy case because the coefficient here would be a, this is b, and this is c. In easy cases, a equals 1, so we just see the x. Now, to factor this, we would need to find two numbers that will add up to get negative 8, and that will multiply together to get positive 12. For this, I'm going to use the diamond method. I'm going to find two numbers whose product is 12. And so I have 6 and 2, 12 and 1, and 3 and 4. Now I need to find their sums. 3 and 4 is 7, 12 and 1 is 13, and 6 and 2 is 8. But 6 plus 2 equals 8, not negative 8. By the way, those are the two we're going to use. So if we change the signs, we would get negative 6 plus negative 2 equals negative 8, and negative 6 times negative 2 is positive 12, because a negative times a negative is a positive. Now we'd write this in parentheses over here like this. X minus 2 times x minus 6. You can write it either way. You can switch these two and write x minus 6 times x minus 2, and it'd be the same thing. Now the thing I like about these is that you can easily check it using distributive property. So I did x times x equals x squared. X times negative 6 is negative 6x. Negative 2 times x is negative 2x. And negative 2 times negative 6 is positive 12. So the negative 6x and the negative 2x add together to get negative 8x, and we get the answer as up here. So this would be the correct answer, or the correct factor for this expression. Our last expression involves the difference of two perfect squares. So we have a squared minus 16. What we're going to do is find the square roots of a squared and 16. The square root of a squared equals a, and the square root of 16 is 4. Now we need to set this up as an equation. We'll use the exact same equation as the easy case quadratic trinomial. We'll put it in parentheses, so a plus 4 times a plus 4. However, 4 times 4 is 16, not negative 16, so we have to change one of the signs of the 4. So we have a plus 4 times a minus 4, and this is how our answer would be written. Once again, we can check it using distributive property. So we have a times a, which is a squared, a times negative 4, which is negative 4a, 4 times a, which is 4a, and 4 times negative 16, 4 times negative 4 equals negative 16. The two 4's cancel out because a negative 4 and a positive 4, and we get a squared minus 16, as up here. So this answer would be correct. That is how you factor a quadratic expression.